Hi guys, welcome to this video looking at the displacement reactions in precipitate reactions. So in this question here we have copper sulfate solution. Now this question is asking for the balanced equation with state symbols. So the fact that it says solution means I've got CuSO4 aqueous. Sodium hydroxide solution is NaOH. Again, the solution means aqueous, so I can put that in as my reactants. Then it says to form a precipitate, that's key there, of copper hydroxide, which it gives you the formula CuOH2. So I'll put that in, and the precipitate means it's going to be solid. It then says it also forms sodium sulfate solution, so that's Na2SO4, and because it's a solution, it's aqueous. So this question has given you all the information you need. I've included my state symbols, that's given me one of my marks. I've done my reactants, that's my second mark, and third mark. All that's left now is to balance it. So you count up what you've got on either side. So in this case I've got copper, sulfur, oxygen, sodium and hydrogen. On the left I have 1 copper, 1 sulfur, 4 oxygens in copper sulfate, 1 sodium, 1 hydrogen, and then another oxygen in sodium hydroxide, so I've got 5 in total. On the right hand side I've got 1 copper, I've got 1 sulfur, I've got 2 oxygens, and then I've got 4 over in my sodium sulfate, so I've got 6 in total. My sodiums I've got 2, and then finally my hydrogens I've got 2. So at this stage my copper and sulfur are balanced, but my oxygen, sodium and hydrogen is not. Now conveniently, if you have a look on the left hand side, there is a compound there with sodium, oxygen and hydrogen. So if I double that, that doubles my oxygen there to 2, so I have 4 plus 2, which gives me 6 in total, which balances it. I double my sodium, so that becomes 2, which is now balanced, and I double my hydrogen, which is 2. So sometimes it can be nice and simple, it can be just a case of changing one thing, and usually it will be with these displacement reactions. The real challenge in these displacement reactions is actually being able to work it out from scratch, including working out the formula. So this one says aluminium chloride and sodium hydroxide solutions react together and it forms a precipitate of aluminium hydroxide. Write a balanced equation including state symbols. So if you get a question like that, you've got to break it down into parts. And I'd always start off with doing the word equation. So take the information from the question. So it says aluminium chloride reacts with sodium hydroxide, so that will be aluminium chloride plus sodium hydroxide to form aluminium hydroxide. And then we've got something else, you can't just leave it at that. We've got sodium left over and we've got chlorine left over, so we're going to have sodium chloride. Now the next step is to work out the formula of all the ions. There are links here if you need to go back and actually work out how to do that. I'm going to presume that you can do it at this stage. So aluminium is in group 3, therefore it loses 3 electrons, becomes positive, so it becomes Al3+. Chlorine is in group 7, so it gains 1 electron and becomes Cl-. Sodium is in group 1, so it loses 1 electron and becomes Na+. And then a hydroxide ion, you just need to be able to remember, is OH-, which you can see in the ion recap video. Now from that you can work out the formula of the compounds. So I've got Al3+ and Cl- to make my aluminium chloride. Remember, rub out the charge. I then swap the number around, so that 3 goes down below the chlorine. So my formula for aluminium chloride is AlCl3. For sodium hydroxide I have Na+ and OH-. Rub out the charges, there's nothing left to do, so it becomes NaOH. It's already balanced. When we want to move on to aluminium hydroxide, I have Al3+ again, and then OH-. Now because this is a compound ion, we start off doing the same thing by rubbing out the charges. I move my 3 down to the bottom of the OH-, and then because it's a compound ion we put it in brackets. So I get Al in brackets OH3. And last but by no means least we have sodium chloride, which is Na+ and Cl-. The charges are already balanced, they cancel each other out, so my formula for sodium chloride is NaCl. Now that will get you the first 2 marks out of the 5. The next job is to actually balance it. So count up what you've got. In this case I've got 1 aluminium on the left and 3 chlorines, 1 sodium, 1 oxygen and 1 hydrogen. On the right hand side I've got 1 aluminium, I've got 1 chlorine, I've got 1 sodium, I've got 3 of my oxygens, and then I've got 3 of my hydrogens. So this one's a little bit more difficult to balance. However, what we can do is look at the ones that are unbalanced, which are the chlorine, the oxygen and the hydrogen, which I've got 3 of each. And then normally I'd tell you to find the biggest compound with the odd number in and double it. However, in this situation and with most displacement reactions, there's no need normally to do this. Look at the ones that are unbalanced. I need 3 oxygens and 3 hydrogens. So let's start by doubling my NaOH. So that gives me 3 sodiums as well. Now my oxygens and hydrogens are balanced, but my chlorines and sodiums aren't. I need 3 of both of those now. So if you go over to the right, conveniently sodium and chlorine are both in the same compound, so I can times them by 3 as well. So 1 times 3 for both of those gives me 3 in total for each, and therefore I'm balanced all the way down. Now remember, you're not finished there. The last step is you need to put the state symbols. If you forget that, you're going to lose some easy marks. So it tells you sodium chloride and sodium hydroxide are solutions, so they're aqueous. You've got a precipitate of aluminium hydroxide, so that is going to be a solid, and then sodium chloride will stay in your solution, so that is going to be aqueous as well. So you get 1 mark for your left hand side, 1 mark for your right hand side, 1 mark for the balancing, 1 mark for your state symbols, for 4 in total. And if this was worth 5 marks, like I said in the first place, you get that for getting the formulas correct as well. Right, we'll do one more example then. Now this one involves something that says iron 3 and copper 2. So I'm going to explain what that means. So let's start off. So we've got a displacement reaction occurring when iron 3 reacts with copper sulfate solution. Write that balanced equation. Now these are transition metals, so you can't actually work out the charge from the periodic table. But what you can do is, if it gives you this, is work it out from the actual sentence. So Fe3 means Fe3 plus, and Cu2 means Cu2 plus, and that's all you need to be able to do this equation. So if I start off with iron and write out my word equation, it's iron plus copper sulfate, and then it's a displacement reaction, so you should realise now that you just need to swap them around. So I'm going to get iron sulfate plus copper, and then you need the charges. So your second step is to work out the formula. Iron you find on the periodic table is Fe, and then the charge is 3 plus, which you can get from those brackets in the 3. Copper is Cu2 plus, and then sulfate you need to remember is SO4 2 minus. Again, check the iron recap video and that will tell you that. Then what we need to do is work out the actual formulas. So iron is just Fe, copper sulfate you have Cu2 plus and SO4 2 minus. So the first thing you do is you cancel out the charges. Now because they're already balanced, you don't need to do anything else, so you just put your Cu and your SO4 together and have CuSO4. Iron sulfate however is slightly different, so we've got Fe3 plus and SO4 2 minus. So we do what we used to, we rub out the charge and then swap the numbers around. So that 3 goes down to the bottom of the SO4 and the 2 goes down to the bottom of the Fe. Now we've got a compound iron here, so SO4 with that 3 down below you need to put into brackets. So it's Fe2 in brackets SO4 3. And then copper is Cu. So all that's left now is to balance. So I've got 1 Fe, 1 copper, 1 sulfur and 4 oxygens on the left. On the right I've got 2 Fes, 1 copper, 3 times 1 is 3 sulfurs, and 3 times 4 is 12 oxygens. Now again, you might think this is quite difficult, but don't worry too much about that. Have a look at the ones that are balanced, which is just copper at the moment, and then choose one to actually balance. So let's start off with the oxygen. I've got 4 times by 3, so I've got 12 on the right, so let's do that on the left. So if I've got 4, I need to times it by 3 to give me my 12 in total. That changes my copper to 3 and my sulfur to 3 as well. So the sulfur and oxygen are now balanced, but my copper isn't. all that I need to do there is put a 3 in front of my copper, so 3 times 1 gives me 3 on the right, so that's balanced. And then all I'm left with is my iron. I've got 2 on the right, so I need to times my 1 by 2 on the left, and then my whole thing is balanced. Again, don't forget the state symbols. So iron, you know, is a metal. If it's a metal, that's going to be a solid. Copper sulfate, it tells you it's a solution, so that's aqueous. And then your copper is going to be a metal, and you're going to be left with a solution again. It's just going to swap round. So 1 mark for the reactants, 1 mark for the products, 1 mark for the state symbols, and 1 mark for the balancing. Right guys, that ends this part of the video. What I'd like you to do is go back to the balancing equations for displacement reactions video and have a go at the review section. If you click on the link here, it'll take you straight back to it, but you can close the tab. Hi guys, hope you enjoyed the video. If you did, click on the subscribe button down below, visit the website, and you can find me on Facebook and Twitter.